Hello everyone, welcome to the ITLS Academy. Today we are going to discuss the topic that is your methods of the preservation and determination of the shelf life of milk and milk product. Okay, so preservation and shelf life, these two preservation and this is your shelf life, they are the interconnected. Okay, when the food are preserved, when the food are preserved, then their shelf life will increases. Their shelf life will increases. Okay, that means that this preservation and the shelf life are interconnected. So in today's lecture, we are going to discuss about the different methods of the preservation and the determination of the shelf life of milk and milk product. Okay, preservation means that simply preservation means that increase the shelf life of the product. Increase the shelf life of the product. Now, what does this shelf life means? Okay, see, the shelf life is simply means that the duration at which the product, the food products can be consumed. Okay, and it depend upon the different factor. Okay, like moisture content, acidity, nutritional concentration, yeah, nutritional value. Okay, so all of these are the factor which affected the shelf life of the food product, or here we can say that the shelf life of the milk and milk products. Okay, if the moisture content and high, if the moisture content are high, that means that it is easy for the microorganism to attack on them, to attack on them, and their shelf life will decreases. Okay, and if the again, if the moisture content is low, then there is less chances of the growth of the microorganism, and it will not affect the shelf life of the product. So in today's lecture we are going to discuss about all of these things, that what is the different method for the preservation of the milk, and what is the different factor which affected the shelf life of the milk and milk product. So let's start today's lecture. First of all, we are going to see the basic definition of this raw milk. Okay, so we already discussed about the in detail in the lecture introduction of the milk and milk product. At that lecture we are already discussed about the definition of the milk, and all these, the basic of all of these are already discussed. Here we are just only go to quick recap of these. Okay, so this milk are what they are: a lacteal secretion practically free from colostrum, which are obtained by a complete milking of one or more healthy cow. Okay, PMO. Here, raw milk are what they are: a lacteal secretion, and they are free from a colostrum, and it is obtained by a either complete milking of either one cow or more than one cow, one more than one healthy cow, and it is considered as a PMO. Okay, now the consumer's milk product, that is homogenized milk, contain a less than or equal to 3.25% of milk fat. Okay, reduced fat milk contain 2% of the fat, low fat milk contain around 1% of a fat milk. Okay, and fat free milk or skim milk contain less than 0.5% of the milk fat, and all with 8.25 solid and non-fat. So this is the composition of the you can say that composition of the milk and uh, sorry, composition of the fat. Just a minute. Composition of the fat and SNF. Okay, Other milk product like your lactose reduced milk, heavy cream milk, culture milk, yogurt, cottage cheese. They are what? They are the product of the milk. Products of the milk. Okay, now come to the next slide. Contamination of the milk and milk product. Okay, so when we are going to discuss about the preservation part or shelf life of the milk and milk product, shelf life of the milk and milk product. So before uh, discussing the preservation and shelf life part, we have to know that what is the contamination occur in milk and milk product. Contamination means that any foreign, any unacceptable material added either intentionally or unintentionally into a milk or milk product. Means that they are not acceptable, they are not the part of the milk and milk product, they are not the ingredients of the milk and milk product, but they are either intentionally or unintentionally added into a milk product, and it will contaminate the milk product. Means that it will change the composition, it will affect the shelf life of the milk product. That is called a contamination of any like here we can we are talking about the milk and milk product, so here it is called a contamination of the milk and milk product. Okay, so we are going to discuss about it. Milk is sterile at secretion in the udder but contaminated by a bacteria even before it leaves the udder. Okay, so at the time of the secretion, the milk is totally sterile. Okay, when a milkman milking the milk from the cow, at that time, like you can say that at a few seconds only, the milk is what? The milk are sterile at that time. But as the time changes, or here the bacterial contamination are occur even before the milk are leaving the udder, the milk become a contamination by the bacteria. Further infection of a milk by a microorganisms can take place during a milking, handling, storage, and other pre-processing activities, because we all know that these microorganisms are very tiny and they are present in whole environment. So it will infect the milk by, it will infect the milk during a milking, handling, storage, and other pre-processing activities. Now the next is your few microorganisms which are found in a milk. That is your Streptococcus lactis, Acrobacter, chloroform, and Bacillus subtitles. They are what? They are the common type of the microorganisms which are found in a milk. Now the next is your preservation of the milk. If there is if the microorganisms present into a milk, then we have to preserve it. If the microorganisms are present into a milk, then we have to preserve it. Okay, preservation means that we have to control the growth of the microorganisms either by killing them, either by eliminating them, either by decreasing their number, either by inactivation their activity. So all these come under the topic of the preservation. So if there is a microorganism present into a milk, then we have to preserve it. So we are going to discuss about the different technique of the preservation of the milk. Come to the next slide. Methods of the preservation. So first method is what? Pasteurization, sterilization, dehydration. These all three methods are the preservation, means that which increase the shelf life of the milk. Okay, so this preservation and sterilization are what? They are a heat treatment. Okay, they are what? They are the heat treatment, and this dehydration are what? Removing of the microorganism. Sorry, removing of the moisture content. When the moisture content are removed, then ultimately the number of the microorganism decreases and shelf life increases. Okay, here when we give a heat treatment, then microorganism will be kill or destroy, and when it is destroy, ultimately the shelf life will increases. So that is the methods of the, that is about the methods of the preservation of the milk, that is pasteurization, sterilization and dehydration. Now the next is, the first one is your pasteurization. So what is the main aim of the pasteurization? The main aim of the pasteurization is simply the inactivation, or you can say that the elimination, killing, destroy of the pathogenic microorganism. Okay, because in pasteurization we only target the pathogenic microorganism. Pathogenic microorganisms target the pathogenic microorganism, pathogenic bacteria. Okay, pathogenic bacteria means that which are capable for causing disease, capable for causing disease. Okay, so in pasteurization the target microorganism is Coxella bureti. Okay, it also assures the longer shelf life of the product by inactivation of the spoilage organisms of and many enzyme. Okay, so see what is written here. Purpose: inactivation of the, just a minute, inactivation of the bacterial pathogen, and the target organism is Coxella burnitii. Assurance of longer shelf life, inactivation of the most spoilage organisms and many of the enzyme when we increases the temperature. So this pasteurization are basically the combination of the temperature and time. Okay, here if the heat treatment we give 72 degrees Celsius, then the time will be 15 seconds, and this process is called a HTST, higher temperature shorter time. Higher temperature, high temperature, shorter time. Okay, and the next temperature and time combination is 63 degrees Celsius for 30 minutes, or equivalent, this is called a LTST. Okay, these HTST and LTST are the type of the pasteurization that we discuss in the next slide. It does not kill all the vegetative bacteria or spores, that is your Bacillus species and Clostridium species. Here the target microorganism are what? Coxella burnitii. Pasteurization temperature is continuously recorded. Okay, so pasteurization temperature should be continuously recorded. Now the next is your pasteurization is a process of heating a food, usually a liquid, to a specific temperature for a predefined length of time. That I already told you. This pasteurization are what? It is the combination of temperature and time. Okay, so what we have to do, we heat the food product, and this food product, especially what they are liquid, at a specific temperature for a specific time, and then immediately cooling it after it is removed from the heat. One more thing here, that when we remove the heat, we have to cool it immediately. That's why in our house, what we have to do, after boiling the milk, we put the milk inside the refrigerator. This is the process of the pasteurization. Okay, so here when we remove the heat, we have to keep the milk inside the refrigerator. This process slow the spoilage caused by a microbial growth in the food. Now the history of the pasteurization. Okay, so Louis Pasteur introduced the word this pasteurization. Louis Pasteur introduced this word pasteurization, and Franz von Soxhlet, they will suggest that the milk should be pasteurized in 1886. Okay, Louis Pasteur gave the term pasteurization, but for the pasteurization of the milk, this was suggested by Franz von Soxhlet in 1886. To remedy the frequent acidity of the local wine, he found out experimentally that it is sufficient to heat a young wine to only about 50 to 60 degrees Celsius, 120 to 140 Fahrenheit, and for a brief time to kill the microbes. Okay, pasteurization was originally used as a way of preventing a wine and beer from souring, and it would be a many year before milk was pasteurized. Okay, now the next one. Okay, so this is a pictures of Franz von Soxhlet and Louis Pasteur. Now come to the next one. Types of the pasteurization. Okay, so LTLT, LT, LT, okay, HTST, UHT, and what pasteurization. Here, LTLT is what? It is a low temperature, long time. Means that here we give a low temperature like 63 degrees Celsius, but the time is for 30 minutes. It is called LTLT, low temperature, longer time. HTST, higher temperature, shorter time. That means that we increase the temperature and it will reaches at 72 degrees Celsius. Now the time is for 15 seconds only. Here you see that when the temperature are increases around 9 degrees Celsius, but time is decreases from 30 minutes to 15 second. Now the next is your UHT, that is your ultra high temperature pasteurization. In that pasteurization, we give a temperature around 130 to 132 degree Celsius, and it is only for few second, that is either 2 seconds or 1 second. And the last one is your what pasteurization. Okay, so we are going to discuss one by one. The first one is your low temperature, longer time, or it is called a holding method. I already told you here the temperature is 63 degrees Celsius or 145 degree Fahrenheit, and it is maintained for a 30 minutes. That's why it is called a holding method or a LTLT method. That is your low temperature, longer time or long time. Okay, now the next is your holder process pasteurization. Now what is the uh, step involved in this process? Milk is pumped through a stainless steel into a heat exchanger. Then it will passes through one side of a series of plates which are in contact with a hot water on the other side. Now milk are emerges from the heat exchanger and then passes into a street tank. Then it will heat it for 30 minutes at 60 to 265 degrees Celsius. Then this tank is preferably fitted with a temperature which are recorded clamped to a clock, so that it will ensure that the temperature should be maintained long enough to destroy the bacteria. Now at the end of the 30 minutes, the milk is run out over a surface cooler or through another heat exchanger in which a cold water is run counter current to the milk on reverse side of the plates. Now the next is your HTST method, high temperature short time. High temperature short time. Here we give a temperature around 72 degrees Celsius for 15 seconds. Okay, and it is designed to achieve a 5 log reduction, killing around 99.99% of the number of the viable microorganism in a milk. This method required the milk should be held at 161 degree for 16 seconds. Okay, it is in Fahrenheit, but if you convert into a degree, then it will be a 72 degrees Celsius for 15 seconds. This process also referred to as a continuous flow pasteurization. HTST are considered as a continuous flow pasteurization, and it will require the milk to be forced through a metal pipe that are heated from the outside. Now HTST method required. First of all, we get a raw milk, then it will be regenerated, that is heated. Then the next step is flow access the other side of the heat exchanger plate. Then the next step is the milk is raised to a pasteurization temperature, that is 72 degrees Celsius for 15 seconds. Okay, suppose that this is the passage where milk should be go or passes here. mm, okay, just a minute. Here the temperature will be a 72 degrees Celsius, and milk should be passed through this passage within a 15 second. Passes through the heater unit and remain at this temperature for the time it takes to flow through the holding tubes. The tube that I draw is what it is called a holding tube. It is then cooled first by passing through the regenerator and then through the cooler. This is the whole diagram for the HTST. Now UHT is what it is. UHT is ultra high temperature. Okay, it is produces a product that has a stable shelf life of up to 2 months. Okay, so when we pasteurize the product with the ultra high temperature, then the shelf life of the product will around 2 months. UHT product hold the milk at a temperature 130 degrees Celsius. Here it is a maximum temperature, but you can also held at 132 degrees Celsius, but time is required for 2 seconds. After a treatment, it can pass through a heat exchanger or by a direct injection of live steam. So it is called so-called Tetra Pak process. Okay, so all the Tetra Paks milk are what they are pasteurized by this method, that is your UHT method. Now the next one is your direct stream injection. This is the diagram for the direct stream injection UHT process. Okay, the last one is your what pasteurization. It is most gentle type of the pasteurization. Here the milk are heated around 145 degrees Celsius for 30 minutes. It is then quickly cooled to a 39 degree. Okay, 145 degree Fahrenheit for a 30 minutes. Now the next is your sterilization. Okay, after the pasteurization process, we are going to discuss about the next method of the preservation of the milk. It is the sterilization process. Sterilization means that removing or killing or eliminating the all type of microorganism. All type of microorganisms are removed, kill or eliminate during this sterilization process. Okay, now the next one is your definition of the sterilization. This term are referred to any process that eliminate, kill all form of the microbial life, like your transmissible agent, that is your fungi, bacteria, viruses, spore form, etc., which are either present on a surface, it contain in a fluid, in medication, or in a compound like biological culture media. Sterilization can be achieved by applying the heat, chemical, irradiation, high pressure, and filtration, or the combination of all of these. Okay, so sterilization simply means that we remove the microorganisms from the surface, fluid, medicines, and any compound or biological culture media. All type of the microorganisms should be eliminate, kill, or uh, reduce from all these areas. Okay, and this can be achieved either by the heating, either by use of the chemical, irradiation, high pressure and filtration, or combination of one of two or all of these. So this is referred as a term sterilization. The first one is your Tyndallization. It is named after the John Tyndall. is a lengthy process designed to reduce the level of the activity of the speculating bacteria that are left by a simple boiling water method. It involves the boiling for a period, typically 20 minutes at atmospheric pressure, then cooling, then incubating for a day, boiling, cooling, incubating for a day, boiling, cooling, incubating for a day, and finally boiling again. So tenderization is what? It is a method in which we involve a boiling for a periodically, and it takes typically around 20 minutes at atmospheric pressure. Then we cool it, and then we incubate it for a day. Then again we boil it, then cool it, then incubate for a day. Then again boiling, cooling, incubating for a day, and after that again we boil it finally. So three incubation period are there which allow a heat resistant spore surviving the previous boiling period to germinate the form of the heat sensitive vegetative state, then it again killed by our next boiling step. So when we incubate it, it will allow the heat resistant spores to survive, and then again when we boil it, they will kill it. So this effective because many spores are stimulated to grow by a heat shock, and the process only work for a media that can be support bacterial growth, and it will not be sterilized plain water. Boiling of a meat or milk or heating in a flowing steam, it will destroy all the microorganism except this spore forming bacteria, and it will changes the appearance, palatability, digestibility, and nutritive property of the milk. Steam under a pressure. Evaporated milk is canned and then heat processed by a steam under a pressure, often with accompanying the rolling or agitation. The forewarming of milk at about 93 to 100 degrees Celsius or higher before evaporation, it will kill all but the more resistant bacteria spore remain survive. So then can will be sealed at 115 degree to 118 degrees Celsius for 14 to 80 minutes, which give a result in a commercial sterile product. Refrigerated storage. A raw milk for a pasteurization should be cooled at 10 degrees Celsius or less within a 2 hours. Then after that we kept it at a cool until a process. Now newly pasteurized milk is to be cooled at 7.2 degrees Celsius or less, and then it should be maintained at the particular temperature, and then it is preferable of course to cool it to a temperature well below 7 to 10 degree Celsius. Freezing. Now butter in storage is held at -17 to -18 degrees Celsius or lower, where no microbial growth can take place. Frozen cream is stored in a considerable amount at a similar temperature. Membrane filtration or microfiltration, it is a process in which filtration with a micrometer size. Okay, so here the filtration will occur and the size of the filter is around micrometer. Microfiltration is a membrane technical filtration process which remove the contaminant from a fluid by passage through a microporous membrane. A typical microfiltration membrane pore size of at the range of 0.1 to 10 micrometer. The next method of the preservation of the milk is dehydration. Okay, so we are already completed the two method, that is your preservation and sterilization. Both these method are what? They are the heat treatment. Now the next method is the dehydration of the milk. This dehydration of the milk is what? In this process we remove the moisture. We remove the moisture from the milk, and when the moisture are removed, the milk are converted into a powdered milk. Okay, and their shelf life increases. Okay, here you see that this is your milk component, and when it is passed through this funnel, then it will convert it into a powder form. This is called a dehydration process. Oh, okay, we will discuss in detail. Regular powder milk. Dehydrated milk is manufactured by a dairy product made by a evaporated milk to dryness. Okay, so this dehydrated milk are typically manufactured as a dairy product which are made by a evaporating milk to a dryness. What is the purpose of it? To preserve the milk. We all know that the shelf life of the milk is very low. Like you can consume the milk within 2 to 3 days, but the shelf life of the milk powder is a longer. Milk powder has a far longer shelf life than a liquid milk and does not need to be refrigerated, and even the powder milk should not be need to refrigerated. Just you take a 1 spoon and just put it into a water and your milk is ready due to its low moisture content. That I already told you. What should we do in dehydrated milk? We remove the moisture content. When we remove the moisture content, ultimately the shelf life of the milk will increases. And dry milk are easy to transport. First, it is invented by a Russian physician Osip Krivtsky in 802. Commercially, it is available in 1832 by a Russian chemist M. Dirshov. Okay, invented by a Osip Krivtsky in 1802, but commercially it is available by a Russian chemist M. Dirkov in 1832. Condensed milk. Evaporated milk is made by removing about 60% of the water from a whole milk, so that about 11.5% lactose would be in solution plus twice the amount of soluble inorganic salt in a whole water. That is called your evaporated milk. Evaporated milk is what? Evaporated milk, when we remove around 60% of the water from the whole milk and the remaining 11.5% is lactose which are present in a solution plus twice the amount of the soluble inorganic salt in a whole water. This high concentration of a sugar is inhibitory to the growth of some bacteria. Condensed milk is more concentrated than a evaporated milk. Okay, but the concentrated milk is what? They are more concentrated than the evaporated milk, and they are is still a poor culture medium for the microorganism which not tolerate a high sugar concentration. In a condensed milk, the sugar concentration is very high, which are not tolerated by the microorganism. That's why it contain a poor culture of the microorganisms. Okay, this milk drying method are divided into a three-part: spray drying, freeze drying, and drum drying. These are the three methods. Spray drying. Pasteurization milk is first concentrated in and evaporated to a approximately 50% of the milk solid. First of all, what we have to do, we take a pasteurized milk and then we concentrated it and evaporator so that 50% of the milk solid will remain. Then the resulting concentrated milk is spray into a heated chamber where the water almost instantly evaporate and leaving a fine particle of the powder milk. Then it is passed through a spray heated chamber where the water are evaporated, instantly evaporated, and the remaining fine particles will converted into a powder milk. Next is your drum drying. Milk is applied as a thin film to the surface of the heated drum, and the dry milk solid are then scrubbed off. However, powder milk made this way tend to have a cooked flavor. Okay, when we prepare a powder milk with the drum drying method, then it will give a cooked flavor due to the scrubbing. Due to the caramelization which caused by a greater heat exposure. Next is your freeze drying. Same as the drum drying, but it involve a freezing which retain more amount of the nutrition. If we do a freeze drying, then the nutrition property will retain. Now the next is your uses of this milk, dry milk. It is used in the manufacture of the infant formula, confectionery such as the chocolate in a recipe for baked good, where the adding liquid milk would render the product too thin. It is also used in various sweet like famous Indian milk ball that is called a rasgulla, and it is popular in Indian sweet delicacy. Common item in UN food ad supply, fallout shelter, and it is favored by our surrealist hikers and other requiring non-perishable, easy to prepare food. Reconstitution, how we reconstruction it. We take a 1 cup of the potable fluid milk from a powder milk, require 1 cup of potable water and 1/3 cup of the powder milk that I already told you. Condensed milk. Condensed milk is simply a cow milk from which water has been removed. It is most often found in the form of the sweetened condensed milk with a sugar added. Okay, condensed milk is simply what in condensed milk the water are removed and sweetened condensed milk are available in which the sugar are added. Sweetened condensed milk is very thick sweet product which then can last for a year without refrigeration if it is not open. But once if it is open, then it will kept at a refrigerator and it will consume within a 15 days. Production: raw milk are clarified, sterilized, and then it will be heated between 85 to 90 degrees Celsius for a second. This heating destroys some microorganism and decrease the fat separation and inhibit the oxidation. Now, some water droplet are evaporated from the milk and then we add the sugar approximately 45%, and this sugar are extended the shelf life of the sweet condensed milk. Sucrose will also increase the liquid osmotic pressure which prevent the microbial growth, and the sweetened evaporated milk is cool and lactose crystallization is induced. Now the next is your uses of this sweetened condensed milk. It is preferably used to added into a coffee or a tea. Many countries like Southeast Asia use the condensed milk as a flavor to their coffees. Popular treat in Asia is to put a condensed milk on a toast and eat in a similar way as a jam and toast. Condensed milk are also used as an alternative of the jam, and it is also a major ingredient in many Indian sweets and dessert like your start with normal milk to reduce the sweeten in it, and packed condensed milk has also become a popular. Now the next is your uses of the preservative. So basically different preservatives are used for the preservation of the milk product, and they are what they are: sorbic, propanoic acid, or one of the salt in permeated in cottage cheese, yogurt, and some of the hard cheese and processed cheese. Now, addition of the preservative in a cottage cheese and yogurt is also prevent the growth of the mold on the surface of the product and also extended the shelf life of the product. Sugar will also added as a preservative of the sweetened condensed milk, and it also reduce the moisture content and making the moisture unavailable to the microorganisms. Sodium chloride or the common salt are also added in the manufacturing of the various product like your cheese, but usually it is more flavor or so for controlling the growth of the microorganism during the manufacturing and curing than the preservative of finished product. Carbonated milk, butter, and ice cream has been tried as an add in a preservation but without much success. Now, this cheese are smoked primarily for the addition of the flavor, although the drying, especially of the drained chemical preservative from a smoke, may improve the quality. Mold spoilage of cheese delay or prevented by by the sorbic acid, propanoic acid, sorbinate or propionate, and the addition of the hydrogen peroxide with the combination of the heat treatment, also using the pasteurization of milk for a certain kind of the cheese, that is your Swiss and cheddar cheese. Develop preservative. Most of the fermented product are microbiologically more stable and they have a longer shelf life than a initial substrate. Fermented milk cheese are preserved by a partially developed acidity produced by a bacterial sulfur culture, and therefore they have a longer shelf life than a fluid milk. Uses of the enzyme in a milk product: different enzyme like your proteinase, lipase, lactase, beta galactosidase, renin, and fruit enzyme are used in a milk product. There are four proteinase enzyme like bovine, porcine, pepsin, and acid proteinase of mucormyces and M. fusilus are regarded as a suitable substitute for the rennet. Lipase cause considerable food spoilage through a hydrolytic rancidity, and the principal application of this lipase is in cheese manufacture, particularly hard Italian varieties. Lactose is the most dominant carbohydrate which are present in the milk, and the presence of lactose in some food preparation is desirable to stabilize the flavor, taste, and texture. And it also act as a reducing agent to bring about a Maillard browning as a source of desirable flavor and color. Beta galactosides are widely distributed in plant, animal, and microbial sources, and the enzyme which are produced from a aspergillus niger, that is your pluriveromyces lactis, cray fragilis, and E. coli are the commercially available. Renin, these are the enzymes which are secreted by a young calves, bring about the coagulation of the milk. Renin also act as a general proteolytic enzyme on all type of protein component, and when casein are precipitated by the action of the renin, the calcium is not released to the way but remain attached to the casein. Therefore, this cheese made with rennet is much better source of the calcium than the cheese which are made by a acid precipitation. Crude enzyme like your bromelain, proteolytic enzyme from pineapple, digested protein changes the gelation of the compound and do not form a gel. The enzyme bromelain clot the milk and digest the clot. All the fruit which contains some organic acid but not always in a sufficient concentration, it will cause a curdling of the milk. Destroying of the enzyme before the combining of the fruit with the milk prevent a curdling, and it is caused by a enzyme action by balancing or by using a canned fruits. Salting also act as a antiseptic, and it will slow down the development of the microorganism and improve the storage life of the cheese and speed up the drying process and formulation of the rind. Milk product like your curd, butter, evaporated milk, toned milk, cheese, buttermilk, ghee, condensed milk, and dry milk. Milk product, first one is your cheese. Cheese is what? Cheese is a food which is derived from a milk, and it is produced in a wide range of flavor, texture, and it will form by the coagulation of the milk protein that is called a casein. It also comprises the different protein and fat from a milk, usually the milk of cow and buffalo, goat, and sheep. During the production of the milk, it is usually acidified and adding the enzyme rennet which cause a coagulation. Fresh cheese or unripe cheese, they are coagulated under the action of the lactic acid fermentation in the milk instead of adding of the rennet. While they are drained after the formulation of the curd, they are either ripe nor fermented. This category includes cottage cheese, ricotta, mascarpone, cream cheese, and quark. Fresh cheese are mainly used in baking and dessert, plain or flavor with a vegetable, fruits, herbs, or spices. Soft cheese are ripe for relatively shorter period of the time before being drained, and it will turn into a mold without being pressed or cooked. They have a moisture content around 50 to 60% and fat content around 20 to 26%. Blue vein cheese. Cheeses are neither cooked nor pressed. The curd is inoculated with the species of blue green mold, which is injected into a cheese by means of long needles. Butter is also a dairy product which consists of butter, fat, protein, and water, and it is made by a churning the fresh or fermented cream or milk, and it is used as a spreader and condiment, and also used in cooking such as baking, sauce making, and pan frying. It is commonly made from a cow milk. Butter can also be manufactured from the milk of other mammals like sheep, goat, buffalo, and yak, and produces sometime by the addition of the salt, flavoring, or preservatives. Storage condition and shelf life of dairy product. Okay, the first column is about the product, then temperature, then RH, then shelf life. First product is your cheese. Okay, and blue cheese whose temperature range is between 0 to 1.1 degrees Celsius, RH is 70, and the shelf life is around 3 to 6 months. Cheddar cheese, temperature around 0 to 1.1 degrees Celsius, RH 70%, and shelf life is around 12 months. Cream, 0 to 1.1%, 0 to 1.1 degrees Celsius temperature, RH is 70%, and the shelf life is around 4 weeks. Pasteurized, 0 to 4.4 degree Celsius temperature, no information about the RH, and the shelf life is around 6 to 10 months. Swiss, 0 to 4.4 degrees Celsius temperature, RH 70%, and shelf life is around 8 to 12 months. Milk, first one is your evaporated milk, 0 degrees Celsius, shelf life is around plus 1 year. Condensed milk, 4.4, 10, and 21.1 degrees Celsius. When it is at 4.4 degrees Celsius, then the shelf life will be 6 to 12 months. When it will be at 10 degrees Celsius, okay, if the condensed milk are kept at 21.1 degrees Celsius, then the shelf life will around few week. Okay, if there is a HTST product, means that the high temperature shorter time, that the temperature range is 72 degrees Celsius and the time will be a 15 second. So at that time, the shelf life is around 2 to 3 weeks. Now the next one is your storage condition and shelf life of a dairy product. Again, if it is HTST, then the temperature range is around 1.6 to 4.4 degrees Celsius. Then the shelf life is around 2 to 3 weeks. If the temperature range is around 1.4 to 7.2 degrees Celsius, then the shelf life is 1 to 2 week. If there is a UHT product and the temperature range is around 1.6 to 4.4 degree Celsius, then the shelf life is around plus more than 1 month. Non-fat dry milk, if the non-fat dry milk, if the temperature is at the range of 4.4 degrees Celsius and RH is 60%, so the shelf life is around 10 months. 21.1 degrees Celsius temperature, RH 60%, and the shelf life is around 5 months. Temperature range is around 37.7 degrees Celsius, RH is 60%, and the shelf life is around 2 months. Okay, so this is all about the preservation and the uh, determination of the shelf life of the milk and milk product. I hope you will understand. If you have any query related to this topic, you can ask me in a comment box, or for a further detail, you can follow the ITLS Academy on different platforms like Instagram, Facebook, Twitter, YouTube, WhatsApp, LinkedIn, and subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. Or for any detail, you can also ask your query to the helpline number that are already mentioned in your slide, that is 7080833450, and visit our website www.itlsacademy.com. Thank you for watching. Please like, share, and subscribe our channel.